When you need to determine which of multiple possible classes something is, you can use multi-class classification. For example, maybe an Antarctic researcher needs to take measurements of penguins and use them to determine the specific penguin species, Adelie, Gentoo, or Chinstrap. We can assign a numeric label to each class, in this case 0, 1, or 2, and we can collect some observations for which we already know the penguin species. The flipper sizes we've measured are our features or X values, and the species identifier is our label or Y. There are two ways we can calculate a prediction for Y based on X. We can use a one versus rest or OVR approach and create functions that consider each class in turn, calculating the probabilities that Y is 0, 1, and 2 for a given value of X. We then compare the outcomes and predict the class with the highest probability. Or we can also use a single multinomial function that produces a vector with a probability value for each class. The values in the vector add up to 1, with the highest corresponding to the most probable class. Whichever approach we use to define the predictive model, we can then take some observations with known species labels that we held back and compare the actual labels to the ones predicted by our model. Then we can tabulate the results in a confusion matrix that compares the actual and predicted label for each class, and use the values in the confusion matrix to calculate metrics like accuracy, recall, and precision for each class, and as an overall average. Multi-class classification is a great way to determine which one of a known set of classes something belongs to. But what if you don't know the classes ahead of time? Next,